Hey calculus folks, here's a answer key for the related rates implicit differentiation review. Hopefully you've been practicing because this stuff doesn't just happen. You got to put in some work. So I'm going to do this a little out of order. I'm going to do the implicit first because they're more like, math problem-y, and they're used in related rates. So it says differentiate with respect to x. So we're going to d over dx everything. And you do it to each. And remember, you pay a penalty every time you take the derivative of something that isn't an x. So if you do an x, no big deal, right? 3x to the fourth becomes 12x to the third. You do the derivative of 5y squared, you treat it like 5x squared, and you get 10y to the first. But since it doesn't match the letter, you have a penalty of y prime. Derivative of 7 is nothing, right? Derivative of 9y to the 6th is 54y to the 5th, and then you pay a penalty because it doesn't match the letter. And then derivative of 32 is nothing. Okay, so now my goal is to get y prime by itself. And right now I see there's y primes on both sides. I think it would be easier in this case to take this guy this way because you already have a 12x cubed over here. So 54y to the 5th y prime minus 10y prime. So now that I got them on the same side, I can pull out a y prime from each of these using GCF. Right, so we're going to have y prime, oops, that equals, okay, y prime times, parentheses, 54y to the 5th minus 10y. And then I divide both sides by that crazy looking thing. And up top, we'll have finally y prime equals 12x to the third over 54y to the 5th minus 10y. That's your answer. Awesome. Now if you took them to the other side, all the signs would be different. No big deal. Same deal here, but what's weird about these is sometimes they're sneakier with a product rule. You have to see that like this is your u and the y is your v. Okay, so when you do the derivative of the right side, it's easy. When you do the derivative of the left side, you have to be like, okay, u prime, so 8x, that's u prime, v you just write y. No penalty on that one because I took the derivative of an x. Plus v prime, which is 1, but you have a penalty, and then times u. And then your goal is to get y prime by itself. There's only one of them, so get the other guy out of there. Y prime times 4x squared equals negative 8xy. And then divide both sides by 4x squared. And you'll have y prime equals negative 8xy over 4x squared. Now if I ask you to, like, a very common thing for me to do is ask you to plug in a slope. You put in the x part for x and the y part for y from each point. So now we got probably the hardest one in this bunch anyway, because it's got, regular problems and it's got product rule mixed in. So here we go. Last one of these. Derivative of y cubed is 3y squared, but penalty because you took the derivative of y. Here we have a u and a v. Right, there's u and v. So we need u prime, v, no penalty, plus v prime, penalty, u. Okay, now we do the derivative of the other side, no big deal because no penalty there. This one you do have a penalty. And then you collect all the y primes to one side. So I think the easiest thing would be bring that guy over there, bring that guy over there. So 3y squared y prime plus 2y y prime times 3x minus y prime equals 8x minus 3y squared. Okay, now I get all the y primes out with a little GCF. What's left inside? Most people are cool with this one. Heck, you're even cool with this one. I'll put these two numbers together. So 6xy. It's pretty typical to write that. 3x times 2y is 6xy. And then here, some people make a rookie mistake and say it just goes away. It's actually -1. Think about distributing. You're taking out 1y prime. And then you divide by that ugly mess. Alright, so implicit is not that hard. It's just remembering to do the penalty if you ever take the derivative of something that has a different letter in it, which relates to related rates. 3y squared plus 6xy minus 1. Because every time we do a problem in related rates, it's going to have differentiate with respect to time. So you should have your list of steps. The only thing you got to do, here they are, draw a picture, general equation, particular information, I guess it's zeros, read the problem. Derivative, plug in, solve the circle. Okay, and then word answers. So really we have a 0 and a 7, but an emu named Carl is flying at an altitude of 2 miles and passes directly over a radar antenna. When the direct distance diagonal between the emu and the antenna is 4 miles, the radar detects the direct distance is changing at 50 miles per hour. Okay, so this is very similar to our UFO problem. You basically have a radar tower, right? We'll draw like the one you see when you go towards Easton, right? Okay, there's our radar tower. The emu flies above. We got our emu over here. Emus are kind of like ostriches, just a little smaller. You can't ride an emu. Well, I mean, I don't think they'd like it. Okay, there's an emu. Not bad, not bad. Give them beefier legs because they don't fly. All right, so we got the height, we got a direct distance, and a horizontal distance. So on this one, you should recognize this as a right triangle problem. Okay, I got to put the 2 on here because it says it's flying at an altitude of 2 miles. So the whole time you're up at 2 miles. This is a Pythagorean Theorem problem. So my general equation in this, it's step 2 here. Step 1, I guess I renumbered them. All right, step 2 is write your general equation. So this is Pythagorean Theorem. You have a right triangle. So we have x squared plus 2 squared equals y squared. And there's just 2 variables, which is awesome. So let's see, let's write that again. X squared plus 4 equals y squared. So our step 3 is, I kind of usually switch these two. Let's see. Find the derivative. Okay, so we're going to find the derivative. And that would be 2x, x prime. Remember, we're taking the derivative with respect to time. So none of them match. You're going to have to pay a penalty every time. This turns into a 0, because derivative of a constant is still 0. 2y, y prime. And now, look at all the things I need in my particular info. Okay, I need an x, I need an x prime, I need a y, I need a y prime. Let's see what we can hunt for back here. When the direct distance diagonal between the emu and antenna is 4 miles. So that sounds like how big regular y is. Okay, 4 miles. We got our units on there too. The next part is the radar detects the direct distance is changing at a rate of 50. So that's y prime because it's the rate at which y is changing. 50 mph. Okay, it says what's Carl's speed? That would be x prime. So here's a sneaky part. If I did all that and I still need one of my variables, there's a way you can go back to the problem and plug in and find out. Because at this particular time, you know 2 sides of the triangle. Because this is still 2. I wasn't allowed to put in the 4 earlier, but I am now because I need to find out what x is at that particular time. See how like I know this at the particular time, I know this at the particular time, I'm looking for this. So I'm allowed to plug in this and do a little Pythagorean theorem and say, okay, here's 4 plus x squared equals 16, x squared equals 12, x must be radical 12. I'm going to leave it as radical 12 for now because I'll have a more exact answer. Okay, step 5 is, hold on, let me get to the punchline here. The news can't fly, so this is ridiculous. Step 5 is plug it in this case, whatever our numbering system. So we're going to plug in here. So now I have 2 times radical 12 times x prime equals 2 times 4 miles. Both these are miles. Times 50 mph. Okay, and we're going to divide both sides by 2 radical 12 miles. And x prime is going to be 57.74 mph. So he's flying at 57 miles per hour. I'll say put word answers. Carl is flying at 57.74 mph. Awesome. Very cool. Emus can't fly still. Okay, so we'll get the next problem set up at least before I got to do a second video because I want to make sure we get all this stuff in 2 videos. Hot air balloon is inflated with hot air, obviously, at a rate of 400 cubic feet. When I see cubic, I'm like, oh, that's a V prime, right? Because cubic means volume, and per minute, when you see per, you have a prime. How fast is the balloon's radius increasing the instant its radius is 5 feet? So that's r. I'm going to use that later. So when you first do this, we can draw a picture, okay, right? Well, we read. So we're going to draw a picture of a sphere, right? Put a little balloon on there, and it has a radius. Okay, no, not a crazy thing here. We got our equation is volume of sphere. Okay, volume of sphere was 4/3 pi r cubed. Okay, and then 2 variables, awesome. That's great. So we're ready to derivative, which is v prime equals 4, because you do 3 times the front, pi r squared r prime, penalty, right? So now when I go for particular, look what I need. I need a v prime, I need an r, and I need an r prime. Well, if I go back to the problem, I see my v prime. That's cool. I got 400 cubic feet per minute. I have 5 feet, and then I don't know my r prime. So we go to the plug-in step. That's all. Okay, so plug-in would be 400 cubic feet per minute equals 4 times pi times 5 feet squared. It's going to be important when you get units to work. And I'll keep it going here. So r prime, I'm going to divide both sides by 4 pi 5 feet squared. Because that'll be 25. So I'm going to go 400 divided by 4 pi times 5 squared, all in parentheses. And my feet squared will cancel out with my feet cubed, and I'll be left with feet per minute, because the per minute doesn't go anywhere. So we get 1.27. So r prime is 1.27 feet per minute. And then I put a word answer with that. And we say the radius, since it's positive, was expanding or growing at 1.275.